Hello everyone, here the question is from the chapter Simple Harmonic Motion. So let us move to the question. If the earth were a homogeneous sphere, so here we are going to considering that the earth is going to be homogeneous sphere. So what is meant by homogeneous sphere is the radius throughout the surface and the center of, so anywhere any one of the point in the surface to its center is going to be same r. Okay, throughout this is going to be the radius is going to be r. Okay, same. So that's what the homogeneous sphere. Homo means same. Okay, so but we know that earth is not in a spherical in shape. You can able to note it down that, so it is little bit flat and flat at upper and the lower end. Only these two ends is going to be curved. So that's what the real shape of the earth, but here we are going to considering it as homogeneous sphere. A straight hole were bored in it through its center. So you can able to see in this image. So this is the center of the sphere. Let us consider this is a sphere. So a straight hole is bored through its center. Okay, body is dropped into the hole will execute a simple harmonic motion. So they are asking question to us. Yes. So how you can able to prove it is, so I'm just taking this as a center point. So this is a center of, so this is the point center. Okay, so I'm just going to draw a time. So I'm just going to draw a time. So this is actually time. So time period, it is going to be showing the time period. Okay, so you must understand this. And if a object, so I'm just taking an object. So if an object is going to be thrown this towards the center due to the gravity, so gravity is going to be act towards the center. We know that the acceleration due to gravity is going to be act towards the center of the sphere. So this is the center, so here this is going to be the center. Okay, so now it acquires more kinetic energy due to this acceleration and just crossing the center point. And again it is going to be due to this gravity. So it is going to, this gravity is going to be stop this velocity. It is going to decrease this velocity, deaccelerate or retardate this velocity, and now it is going to be move in the backward side due to this influence of this gravity. Okay, and again due to the more acquiring more acceleration, so more velocity increases, keyboard increases, there is a more velocity, so it is going to be just travel like this. So and now it is going to be after crossing the center, it is going to be started to deaccelerated by this g. Okay, by this surface. So again it is going to be moved down, the same is going to be repeated, keep on repeating the same thing, and finally it is going to be stopped in the midpoint. So we know that this graph is the time period graph, and this is going to be the motion of the, so this is known as to and fro motion. To and fro motion is called simple harmonic motion. Hence it is going to be acquire a simple harmonic motion. Okay, now the question asked is to calculate the time period of the vibration. So time period of this simple harmonic motion, just I will be erasing this thing and then starting to explain. Here they are given certain values. The radius of earth is said to be 4000 miles. So 1 miles is going to be 1760 meters. 1760 meters, 1.7 kilometer when we say in the kilometer. Okay, so 1 miles is going to be this. So here it is 4000 miles, right? So here 3 zeros is going to be taken place into, here multiplication symbol is going to be taken place. This is called the miles, converting into the meter. So miles is converting into the meter, and the value of g on its surface is going to be 32 feet per second square actually. So this is going to be the acceleration, right? So that's what the thing says. So 1 meter, so we know that 1 meter is equal to 3 feet. Okay, then 32 feet can be written in terms. Okay, so then 1 by 3 meter is equal to 1 feet. So multiplying 32 on both sides, you can able to get, that is this is 32 by 3. So actually this is 32 by 3 is 3 meter is equal to 32 feet. 32 feet. By knowing these values, I'm just going to erase other values. So I'm just going to erase these things So only the requirement is going to be taken place here, going to be left here. So to find it, so normally we have to use the acceleration for the simple harmonic motion is equal to, this is the differential equation of the simple harmonic motion, acceleration is equal to omega square into y is the displacement actually. So as per this concept we have to find the acceleration first of all. To find this acceleration, I'm just going to use the Newton's laws of gravitation. So we know that Newton's law of gravitation, F is equal to, so this is the gravitational constant into capital M is the mass of earth, and the small m is going to be the mass of the object which is thrown into this hole. Okay, a body dropped, okay, small m. So by r square, r is going to be the radius of earth when the object is in the surface. So let us consider the radius of the earth is going to be r. So then when the object is at the surface of the earth, okay, so this formula is going to be taken place. So r square need to be written. Okay, now we know that mg, so Fs can be written as mg is equal to capital G, capital M is the mass of earth, small m is the mass of object, by r square. So just cancelling the small m, so we get G is equal to capital G m by r square. So here in this situation, so the acceleration g is the acceleration due to gravity, so it is going to be inversely proportional to the r square. But whereas according to the simple harmonic motion, gravitational acceleration is going to directly proportional to the displacement. Okay, so directly proportional to r, we have to bring it into in that format. So for that I am just going to take, let us consider the density. So I'm just choosing this color. So I'm just taking the density. If density is equal to mass per unit volume, right? So mass by volume of the sphere is going to be 4 by 3 pi r cube, pi r cube. Okay, so now mass can be written from this equation, mass can be written as capital M can be written as, so suddenly what happened, written as del is the density 4 by 3 pi r cube. Just substituting this m value in this equation, so you can able to get that G is equal to capital G del into 4 by 3 pi r cube, 4 pi r cube by 3. So I'm just substituting this m value in this equation, so this is known as the m value. Yes, this is m value, right? This is m value, you can able to see here. Okay, and here r square. So I'm just going to cancel some of the thing here, so cube get cancelled, this get cancelled. Now you can able to get that G is directly proportional to the r. Okay, so it is going to satisfy with this, A is directly proportional to the displacement. Okay, the other thing you have to find, so now it is going to be satisfied with the equation. So I'm just moving to the next page. Now let us consider, this is the earth. Okay, so I'm first drawing a circle, a sphere first of all. In this, if the object is going to be a certain distance down to the fallen into the, so actually let us consider this is the midpoint of this circle. Okay, I'm just taking it as midpoint. So this distance as r, so the other distance I'm just going to, if the object is going to be present in between these two things, so I'm just taking a small point. Okay, this point, okay, this point, let us consider this distance fallen, the object that fallen into x distance, x depth from the surface. Okay, so now the object is now exactly located here. So down, So the distance between the center and this point, so distance between the center and this point can be written as r minus x. Understood? Understood? So you have to understood this thing properly. If the object is in the depth of x distance from the surface, so then the distance between the center and to this object is going to be r minus x. So as per the concept you must understand. So now the same thing is going to be taken place here. So gravitation force mg is equal to Newton's law of gravitation is going to be capital G capital M small m by now here r minus x whole square. So this m get cancelled. Now G is going to be written as, so G is going to be written, now it can be taken as G dash, because the gravitation acceleration due to gravity will be increased when the distance is going to be closer. Okay, I'm just taking G dash. So G m by r minus x whole square. So this again I am just going to change into the simple harmonic motion. So again I am going to take del is equal to mass per unit volume 4 by 3. Volume of the sphere can be written as 4 by 3 pi r cube. This is r. Understood? So the same thing is going to be taken place here. So m can be written, so instead of writing m I am just going to G dash is equal to capital G. Here again, here I have just missed the thing. So r minus x whole cube here, r minus x whole cube. So I'm just taking only this circle. Okay, this part of a sphere. Okay. Okay, now instead of m I can able to write as del 4 by 3 pi r minus x whole cube. Okay, this is going to be the mass m from this above equation. So here r minus x whole square. Okay, so from this I'm just again cancelling this cube and this whole thing. So G dash is directly proportional to the r minus x, and as well in the previous page you have seen that G is directly proportional to the R. Okay, so by equating these two values I can able to write, okay, I'm just taking equating these two values, G dash by G is equal to, can be written as R minus X by R, sorry, by R. So this is a value. Okay, so we have to find, we have to know the G value, because after falling into this hole, so after falling into the hole it is going to just keep on moving again, it cannot able to come to the surface actually. So since we have to take only this the G dash, so I'm just taking G dash is equal to, okay, uh, G by R into r minus x. So I'm just going to compare this equation with a is equal to omega square. This is in the magnitude, I'm just taking the magnitude omega square into y is the displacement. This is a differential equation of the acceleration. So you have seen here. Okay, okay, so here it is in the normal value, here I'm just taking the magnitude. So by comparing these two equations you can able to note it down that y is nothing but r minus x is the displacement of this object. So this object is falling into this, so it occurs as displacement, is this displacement is r minus x. Okay, so the midpoint is the mean position, so from the mean position is going to be r minus x is going to be the displacement. Okay, so here the omega square can be, here I'm just taking a light color pink. So here the omega square is nothing but G by R. So from this I'm just taking, so time period, so we have to find the time period actually. The question asked here is time period, so we have to find the time period. Okay, so for that reason For that reason, I am just taking time period is equal to, for a simple harmonic motion, is equal to 2 pi by omega. Okay, so from this above equation, I am just told that omega square is taken as g by r. Okay, so I'm just showing you that. Okay, the pink color is going to be omega square, y is going to be displacement, so a is going to be the acceleration, g dash is going to be acceleration due to gravity. Okay, so same thing. So I'm just writing this omega value is equal to root of g by r. So it is satisfying with, so now time period is equal to 2 pi and into 1 by root of g by r. So the time period can be written as 2 pi into root of r by g. Just a minute. Now it's time to substituting the values. So the values given in the question, the radius of the earth is in the meters, is 4000 into 1760 meter. It is equal to 2 pi is the constant value into root of 4000 into 1760 meter can 1 meter can be written as 3 feet. Okay, so instead of I'm directly substituting in the feet itself, so the gravity is given as 32 feet actually in the question, so you can able to rewind, or I will be showing you that the value of gravity is given as 32 feet per meter per second square. Okay, so now feet get cancelled, so by solving this you will be getting, so I'm just solving using the calculator because this is very critical. Already the time is gone. Okay, using calculator, I've got 5105 5105 seconds. Okay, so now in minutes, to convert it in minutes, I'm just going to dividing it with 60. So dividing it in 60, which implies 85.07 minutes. So 85.07 minutes is the time period of the oscillation of the object which is thrown into this hole. And finally, thank you.